In this lesson, I can use long division to divide polynomials by other polynomials. Okay, so long division of polynomials, woohoo! There are two ways to write division. You can either take dividend and divide it by divisor using this fraction bar. That means division. Okay, option number 2 is going to be to take the dividend and divide it by the divisor using this long division bar. Okay, they both represent division. It says when you divide a dividend, f of x, by a non-zero polynomial divisor, d of x, you get a quotient, q of x, and a remainder, r of x. Okay, so again, if I take a function and I divide it by the divisor, my answer is always going to be written as quotient plus remainder over divisor. Okay, you always write your answer as quotient plus remainder over divisor. Okay, just keep that in mind. You might want to box that, star that. We're going to be writing all of our answers in this form. As we prepare for long division, some things you need to keep in mind. The polynomials need to be in standard form, which means you want the highest degree term on the left, and you want it to descend from left to right. Okay, the exponents have to descend by 1. If any terms are missing, you use zeros as placeholders. You'll see what I mean here in a little bit. Here are the 4 steps for long division. We have divide, multiply, and subtract, bring it on down, and bring it on back. Okay, so those are the 4 steps for long division. Divide, multiply, subtract. Yeah, bring it on down and bring it on back. How do I know when to stop? Well, the degree of the remainder will be less than the degree of the divisor, or what you're dividing by. You will find that you run out of expressions to bring down. Okay. Please note that when the remainder is 0, or when you don't have a remainder, it's said that the divisor divides evenly into the dividend. Basically, if there's no remainder, the divisor and the quotient are factors of the dividend. So let's just think about that really quick. Like if I were to ask you for the factors of 8. We'd have 1 times 8 is 8. We'd have 2 times 4 is 8. And I think that's it, right? Those are all the factors of 8. And the reason why is because if I take 8, which is my dividend, and I divide by 2, which is my divisor, it divides evenly, right? I would get 4. See how there's no remainder? No remainder. Because there's no remainder, that's why it's a factor. Okay, now if there is a remainder, then the divisor is not going to be a factor. So over here, like look at what I'm dividing by. See how I'm dividing by 3? Was 3 a factor of 8? No, it wasn't. And I can tell that because look at my answer. Do you see how I got a quotient, but I had this remainder of 2? Right? This is an example where my answer is written as quotient plus remainder over divisor, right? My answer was 2, and then I had a remainder of 2, right? If I think about it, how many times does 3 go into 8? 3 goes into 8 2 times, right? That would get me up to 6, right? 3 times 2 is 6. And then what's my remainder? My remainder is 2, and my divisor was 3. So we would say that this is 2 2/3. Okay. So let's read this down here. Over on the left, it says the divisor 2 divides evenly into the dividend, so we have a remainder of 0. In this case, the divisor is a factor. So if I have a remainder of 0, the divisor is a factor. On the right-hand side, because the divisor does not divide evenly into the dividend, we have a remainder of 2. In this case, the divisor is not a factor. Make sure on a test or quiz that you check whenever you do division, because when you do the check, notice that the inverse is also true. If dividing 8 by 2 gives you 4, then multiplying 2 and 4 together should give you 8, and it does. If dividing 8 by 3 gives you 2 2/3, then multiplying 3 times 2 2/3 should get you back to 8. And if you check this, it does, right? If I distribute the 3 through, we get 6 plus 6/3, which is really 6 plus 2, which is 8. Okay, so that's just a nice way to check our work, is to undo the division, right? Multiply whatever the answer is by the divisor and see if you can get back to your original number. All right, so in example 1, let's go ahead and do this long division process. When we're preparing for division, we want to make sure that everything is written in standard form. So under this division bar, we're going to have x squared minus 9x minus 10. We start with our highest power, and it does descend from left to right. We're not missing any terms, so we don't need placeholders. And we're dividing by x plus 1. Okay. This is called our dividend. This is called our divisor. Okay. So let's go ahead and get started. We're going to divide, multiply, and subtract. Bring it on down and bring it on back. So we're going to divide. So I divide first inside by first outside. So I have x squared divided by x. Subtract these exponents. 2 minus 1 would just be x to the first. All right, and we're going to line this up. I'm going to put this up top, and I'm going to line it up with the other x. Okay, so we're making a column of x to the first. So that's my divide. Next step is multiply. I multiply whatever I got by the entire divisor. Okay, so off to the side, I'm just going to write x times x plus 1. So that's going to be x squared plus x. Again, line this up. See how my x squareds are in a line? And then plus x. See how all my x terms are in a line? That's what we want. Okay, so divide, multiply, and subtract is next. When I'm subtracting this entire quantity, I have to be careful and make sure I distribute the negative sign through to each term. Okay, I like to say to myself, when I draw the line, I'm going to change all the signs, because as I distribute this through to both terms, this is going to become a negative x squared, and this is going to become a minus x. So when you draw the line, make sure you distribute and change the signs. X squared minus x squared, those go away. Negative 9x minus x is negative 10x. Okay. Divide, multiply, and subtract. Bring it on down. You bring the next guy down. So we're going to have minus 10. And then we bring it on back to the first step, and I'm back to my division process. Divide. Well, I'm going to take my first inner and divide it by my first outer. So I'd have negative 10x divided by x. So that's going to simplify to just negative 10. Remember, I'm going to put that up top, lining up all my constants. All right, then after our division, what's next? Multiplication. So I'm going to take the negative 10 that I just got, and I'm going to multiply by everything out front. Okay, so out front, I'll have negative 10 times x plus 1. So I end up with negative 10x minus 10. Divide, multiply, and subtract. Bring it on back down and bring it on back. Divide, multiply, subtract. Right, we're on subtract. When I draw the line, what do I have to do? Well, right now I'm subtracting the whole quantity. So as I distribute the negative through, I have to change all the signs. So this is going to become negative 10x plus 10x. So that goes away. We have negative 10 plus 10. That's going to go away. So it leaves me with 0. Divide, multiply, and subtract. Bring it on down. See how there's nothing left to bring down? And our remainder is 0. Okay, so that's it. So really, if I wanted to write my answer, right, your answer is always written as quotient plus remainder over divisor. If I wrote it like this, we'd have the quotient, which is x minus 10, plus remainder, which was 0 over divisor. And here I was dividing by x plus 1. Okay, now that's not completely simplified. Really, if I'm adding on 0, I don't need to put that. Okay, so really my answer here would just be the x minus 10. Okay, now down here it prompts me to check my work. Right? You have to keep in mind that I just completed x squared minus 10x minus 10 divided by x plus 1, right? That's what I just did. I took the dividend and divided it by this divisor. And what was my answer? My answer was x minus 10. So really, I should be able to multiply these two together to get back to the original expression. So let's see that. Let's see if I get back to my original expression, f of x, if I multiply the divisor, right, d of x, times the quotient. So in this case, let's see if I can get back to the original function if I multiply that x plus 1 and x minus 10 together. Right? Really, both x plus 1 and x minus 10 should be factors because we got a remainder of 0. So in this case, I would get x squared minus 10x plus x minus 10, which, if I combine like terms in the middle, does get us back to our original function. Okay, so that means that we did the division correctly. In example 2, let's go ahead and set up our long division bar here. We have 2x to the 4th plus 3x cubed plus 5x minus 1 divided by x squared plus 3x plus 2. Okay, we have to make sure that they're both in standard form and that we're not missing any terms. Okay, so my highest degree 4 is on the left, and it's supposed to descend. So I have x to the 4th, x cubed. Ooh, I'm missing x squared. So what do I need? I need a placeholder in there for x squared. I'm going to put plus 0x squared. Right, we put a 0 placeholder in here. And then I still have the plus 5x minus 1. Okay, you need to make sure that your exponents descend by 1 going from left to right. 4, 3, 2, this is x to the 1st, and then you have your constant. You need your constant always as well. Okay, if you're missing anything, put a 0 placeholder in. Okay, so now I can start my long division process. Divide, multiply, and subtract. Bring it on down and bring it on back. See what I use? I use purple for divide up top, so we'll do the same thing. Divide, first inner by first outer. We would have 2x to the 4th divided by x squared. Remember, when we're dividing like bases, we subtract the exponents. So I'm going to have 2x to the 4 minus 2 would be second power. I'm going to put that up top. Can I put it here? No, because then x squared would be lined up with x to the 4th. I don't want that. We need to line up our x squared terms. So you can see now why I needed this column. If I didn't have that 0 placeholder in, there'd be nowhere to line up that x squared term. Okay, so that was divide. Then I multiply. Multiply, we'll do that in red, just like what we did in the last step. Okay, so I'm going to multiply this by my entire divisor. Okay, it all gets multiplied. So I'd have 2x squared times x squared plus 3x plus 2. So that's going to be 2x to the 4th plus 6x cubed plus 4x squared. Okay, write that down here. 2x to the 4th plus 6x cubed plus 4x squared. Okay. Then I subtract. Divide, multiply, and subtract. Bring it on down and bring it on back. When I subtract, I draw the line and I do what? Change all the signs, right? When I distribute that negative sign through to each one of these terms, it's going to become a negative 2x to the 4th. a negative 6x cubed, and a negative 4x squared. Okay, so 2x to the fourth minus 2x to the fourth, that's gone. 3x cubed minus 6x cubed is going to be negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. Okay. Divide, multiply, and subtract. Bring it on down. What's next? Bring the 5x down. And then I bring it on back to the division step. So again, I divide first inside by first outside. So negative 3x cubed divided by x squared. Negative 3x cubed divided by x squared. Right? When I divide like bases, I subtract the exponent. So this is really going to be negative 3x to the first. Put that up here. Okay. Then I multiply. What do I multiply? Multiply what I just got from the division by the entire thing out front. Okay? The entire divisor out front. So I'm going to have negative 3x times x squared plus 3x plus 2. It's going to be negative 3x cubed minus 9x squared minus 6x. Okay, so I'm going to line all those terms up. Negative 3x cubed minus 9x squared minus 6x. Okay, divide, multiply, and subtract. So we're on subtract now, the third step. When I draw the line, what do I have to do? Change all the signs, right? When I distribute this negative sign through to all of the terms, this is going to become a plus 3x cubed, a plus 9x squared, and a plus 6x. Negative 3x cubed plus 3x cubed goes away, becomes 0. Negative 4x squared plus 9x squared becomes 5x squared. And then 5x and 6x become 11x. And we divide, multiply, and subtract. Bring it on down. We have a minus 1 to bring down. And then we bring it on back to the original step. So now I'm back to division. First inside divided by first outside is going to be 5x squared divided by x squared. So the x squareds, those divide to give you 1. So really it's 5 times 1, which is just 5, right? That's going to go up top. Line it up with your other constant. Okay. Then I multiply. Again, when I multiply what I just got from the division by the entire divisor. Okay, so I'm going to multiply 5 by that trinomial out front. 5 times x squared plus 3x plus 2. So I get 5x squared plus 15x plus 10. Divide, multiply, and subtract. Right, so I subtract now, draw the line. Right, we're subtracting the whole quantity, so I have to change all the signs. Okay, 5x squared minus 5x squared, that goes away. 11x minus 15x is going to be negative 4x. And negative 1 minus 10 gives me negative 11. Right? Divide, multiply, and subtract. Bring it on down. Well, there's really nothing left to bring down, so I'm kind of stuck. And also, do you see how the degree of the remainder is less than the degree of the divisor, right? If I tried to do negative 4x divided by x squared, I'd end up with a fraction. So that's how I know to stop, is when the degree of the remainder is less than the degree of the divisor, and there's nothing left to bring down. Okay, so with my answer, remember with my answer, I always want to write my answer as quotient plus remainder over divisor. So I have my quotient here, 2x squared minus 3x plus 5. And I need to add on my remainder. Which, what was my remainder? My remainder was this negative 4x minus 11 over divisor. And what was I dividing by? I was dividing by this x squared plus 3x plus 2. Okay. Now notice my answer had a remainder that time. If my answer has a remainder, is x squared plus 3x plus 2 going to be a factor of your original polynomial? No. So this one would be more difficult to check your work on. Like if I was going to check my work, let's see if I would just write it in pink over here, check. It's going to be harder to check my work since it's not a factor, right? Like I took this original polynomial, 2x to the 4th plus 3x cubed plus 5x minus 1, and I divided it by x squared plus 3x plus 2, and my answer that I got was this whole thing, right? That was my answer. Let's see if I can scooch this over a little bit. I'll move it down here for now. So my answer was 2x squared minus 3x plus 5 plus negative 4x minus 11 over x squared plus 3x plus 2. So really, I should be able to take my divisor and multiply it by this whole quotient and remainder. I should be able to multiply these two things together, and it would get me back to my original function. Okay, now those are going to be a pain in the butt to multiply together, so I'm not going to spend the time checking my work on that. Okay, last one. At this point, you should pause the video and see if you can divide using polynomial long division for this example. Okay, welcome back. In this case, my dividend is the numerator. And my divisor is x minus 1. So I'm going to set up my long division bar. I've got x cubed minus x squared minus 2x plus 8. And I'm dividing by x minus 1. Okay, so I check, make sure that it's in standard form and my exponents descend. 3, 2, 1, and then constant. That looks good. And I can start my long division process. Here we go. So I'm going to divide first inner by first outer. We get x cubed divided by x. Really, that's really x to the first. That's going to be x squared. Line it up. Then I multiply by the entire divisor out front. So I'm going to have x squared times x minus 1. So we get x cubed minus x squared. When I draw the line, I have to change the signs, right? So I'm going to change the signs. Here we go. Plus, minus, plus. Add down. Those cancel. Ooh, those cancel too. So really I'm left with nothing. You could put 0 here if you want, but I'm just going to leave it as nothing. And I do divide, multiply, and subtract. Now it's time to bring it on down. And then we bring it back to division. So I'm going to take the negative 2x and divide by x, right? I take this divided by this. And so that's going to leave me with negative 2. Am I going to put it here? No, because it doesn't have an x in the term. So don't put it there. We've got to line it up with the constant. Minus 2. Okay. Multiply that by the entire divisor. So I'm going to have minus 2 times x minus 1. So you get negative 2x plus 2. Okay. So if you look here, right, I draw the line, I change all the signs. So if I change the signs, this is going to go positive, positive, negative, right? Negative 2x plus 2x, that goes to 0. Do you see how I'm going to have to borrow the 8? Right now, this is lined up and I'm not subtracting 2 from anything, but really there's an 8 here. Plus 8. If I have 8 minus 2, that's going to give me 6, right? Then I have nothing left to bring down, and the degree of the constant is less than the degree of the divisor. So that's how I know when to stop. So remember, write your answer. Your answer should be written as quotient plus remainder over divisor. So my quotient was x squared minus 2 plus, what was my remainder? My remainder was 6 over, what was my divisor? I was dividing by x minus 1. Okay. Now, if I wanted to check my work, I could. I'll add one blank page just so that I can show you how I would check my work. Okay, so remember we started with this x cubed minus x squared minus 2x plus 8 over x minus 1. And after we did the long division process, we got our answer was x squared minus 2 plus 6 over x minus 1. Now, it wasn't a factor because the remainder was not 0, but I should still be able to take whatever my divisor is times my quotient and remainder and get back to the original function, right? If I can divide and get this, then I should be able to do the inverse and multiply these two things together in order to get back to the original. It's no different than like if I had 8 divided by 3, right? And that goes into 8 twice. That gets me up to 6. Then I would have a remainder of 2, right? I should be able to multiply 3 times 2 2/3 and get to 8. So let's see if that works. If I do divisor times my answer, let's see if I get back to the original. My divisor was x minus 1. My answer was x squared minus 2 plus 6 over x minus 1. Let's see if I get back to my original function. Now this kind of stinks because it's a lot easier to do when my remainder is 0, but we can still make it work. Let's just see what happens. So here I'd get x cubed. This would be minus 2x. This would be plus 6x over x minus 1. It's going to be minus x squared plus 2. That's going to be minus 6 over x minus 1. Okay, this is something you don't have to do. You don't have to check your work. I'm just doing it to see if I got the right answer. Okay, we would get x cubed. So this one's done. Let's see, minus x squared. Let's see, we have minus 2x. And then we have plus 2. And then we have two things over x minus 1. We've got 6x and a minus 6 over x minus 1. Now this is something we haven't really learned yet. But I could factor out the 6, and the x minus 1s would reduce. So I'd get x cubed minus x squared minus 2x, and that would end up being plus 8. Is that what I started with originally? It is. Yeah, look at that. X cubed minus x squared minus 2x plus 8. Okay, so I know I got my answer correct when I did that long division. Like I said, this is kind of tedious. I normally don't check my answer unless my remainder is 0. And it's something easier to check, like what we saw up here when we did the divisor times the quotient, right? That was a lot easier to check our work.